Hello and welcome to a Reigate Maths video. This video is focusing on the linear programming chapter from the first year of the Decision 1 unit for the Edexcel Further Maths specification. My name's Simon, and in this video we're going to be looking at the two methods for locating the optimal point for a graphically drawn linear programming problem. The two methods are the objective line method and the vertex testing method. You may well be told in the exam which method to use, so you do need to know both. If you're not told, you can use whichever one you prefer. Now, the objective line method involves drawing an objective line onto your graph, lining up a ruler with it and moving the ruler around. The vertex testing method instead looks at every single vertex of the feasible region and then calculates the value of the objective function at all of those. The objective line method tends to be a little bit quicker. The vertex testing method is a little bit easier to do, but both are valid methods. We're going to use the same graph for both of these, but with different objectives for both. So we're going to use the objective line method to minimize c equals x plus 3y. So this might be the cost of something. We can see it's in terms of our decision variables, this is our objective. The first thing you need to do is draw an objective line onto this graph. The key thing is there is one objective function, which is this one, the c equals x plus 3y. That is our objective function. And there's only one of those for any given linear programming problem. The objective line, there are multiple objective lines. The thing that changes for those are the values of c. So what we're going to do is we're going to pick a value for c and draw that line. I generally try and pick small values that are going to be nice and easy to draw on our graph. So if our graph was in terms of sort of hundreds, so instead of having, or tens, so instead of having 1, 2, 3 and so on, it was 10, 20, 30, 40, the value of c I'd pick would be small, but in the same scale as my axes, because otherwise it's really hard to draw. So I'm going to choose, just for the sake of argument, 6. So I'm going to draw the graph of 6 equals x plus 3y, which I've added to the graph here. Now it's important you label it, so we're going to label it with 6 equals x plus 3y, and it's also good to label it as objective line. Now the key thing with both of these methods is that the optimal point, the optimal solution, is going to lie at one of the vertices of our feasible region. Okay, so we can see our feasible region here is a pentagon. It's got 5 vertices. The vertex testing method is about looking at the coordinates of each of those and working them all out, which obviously takes a little bit longer. The objective line method is requiring a ruler. So you're going to take your ruler and you're going to line it up with our objective line. What you're then going to do is you're going to move the ruler to each of the vertices of the feasible region. If we drew a line along our ruler here, like this, this is another objective line. So there would be a value of c for this line. We can see that the gradient of this line is the same as the objective line we drew. So this objective line is another solution to our linear programming problem. This line would give us a particular value for C. It wouldn't give us 6 because that's this line, but it would give us a particular solution. But it's not the solution we want. The values of x and y along this line would give us a value of C, but we know from looking at our graph and where our ruler is that this is not going to give us the minimum value that we want to find. With using the vertex testing method, every vertex, your ruler is going to go through the vertex and is potentially going to cross through some of the feasible region. So we can see at this point here, at this vertex here between this green and the blue line, that this objective line cuts through the feasible region, which means it's not useful at all. Same thing with this line here. At this line, we have our objective line, again, crosses through the feasible region. And we can do that at every single line. And we can see that this one is parallel. So we have some interesting things with this line, but it's not going to be relevant to this particular problem. So let's say I draw along this line, and we can see that the entirety of the feasible region is below the line there. That means that this gives us the maximum of x plus 3y. Because the feasible region is below it. We don't want the maximum, we want the minimum. So if we go all the way back to this vertex, we can see that at this one, the entirety of the feasible region is above our line. Because it's above, that means that this point is our minimum. Now, what I like to do to show that we've used the objective line method is do like I've done here and draw little versions of the objective lines at the various vertices. We didn't need to do this one because it's along the line. Once you've identified which of the points satisfies the objective, we can just look at that point and read it off. So we can see that the minimum C occurs at the point 2, 1. Therefore, the minimum C is going to be x plus 3y, which is 5. So we've found the minimum value of C that is feasible. Remember, we could, we'd find here at this point a smaller value of C. But because it's not feasible, it doesn't satisfy all of the constraints at once, we can't use this point. And that's the purpose of the constraints. Now, if this was a contextual question, so if you'd come up with a linear programming problem yourself from descriptive constraints, where x and y meant something, you would then conclude in context. But that is the objective line method. You use a ruler to line it up with an objective line, move it around until you find the maximum or the minimum value or vertex of the graph. We're going to use the same graph again with a different objective function to show you how the vertex testing method works. So we're going to use the vertex testing method to maximize p equals 2x plus 5y. So the vertex testing method is a little bit more descriptive. It takes a little bit longer, but it is often easier. What you're going to do is you're going to find the coordinates of every vertex of the feasible region. We're going to label them as well, because that's going to help us later on. So we're going to call this one A, B, C, D, and E. Okay, so we're going to find the coordinates of those. Now, with this graph, and with most of the ones where you are using the vertex testing method, you can just read it off the graph. But if you can't, you'll have to use simultaneous equations to work out the point of intersection of the two lines. We're going to work out this objective function at every single one of those points, and then we're just going to look at which one is the smallest or biggest, depending on what the objective is trying to do. What I find quite useful to do with this question is to lay it out in a table. So we're going to have the vertex, and we've got A, B, C, D, and E. We're going to have X and Y, and then our objective function. So at the point A, you can see our X is 2 and our Y is 1. So P is going to be 2 times X plus 5 times Y, which is 9. Very clear, very informative. You're going to do this for each of the vertices, and then we're going to look at how we summarize from our table. So this is what you should get when calculating the objective function at each of the vertices. Now, it might be very, very obvious to you that the point A is not going to give us the maximum value of P. However, because of the way the method works, you must test every single vertex, even if you can see that it's not going to work. It's not going to be the maximum we want. Once we've got this, once we've got our table done, you just need to summarize. So we can see the maximum value of P, so therefore the maximum P is 22 at the point 6, 2. Again, if this question has context, you would need to then summarize in context. So saying the maximum profit is £22 when we use 6 of product A and 2 of product B, for instance. Like that kind of thing. A couple of points that students have a tendency to worry about with this method is the labeling of the vertices. Doesn't matter. Just pick one and label round, clockwise, anti-clockwise. It doesn't matter. The important thing is locating the points or identifying the points and calculating them. So the fact that we've got them in our X and Y column there is fine. The labeling of the vertices just makes it much easier to see which one's which, and also make sure you don't miss any. The last video in this topic is going to focus on a little bit more of those contextual ideas. So what happens if X and Y have to be integers, but the optimal point on our graph does not give us integer values? But that's covered the two methods for solving a linear programming problem graphically in 2 dimensions. Thank you for watching.